Hello guys, welcome back to Maths on African Motifs. We are still on our mathematics N6, and this is chapter 6, which is a combination that we have of the applications of integration and differentiation at the same time. So it's a combination. These are combined applications of both. We have to see the applications of integration and also derivative at the same time. So it's a combination. So where do we apply this? In the calculation of the length and also the surface area that is generated when the curve, whatever that is given, rotates about a certain axis. So this is what we want to know, how to answer these typical questions, because it's just a repetition that you're going to have. All right. So on the arc length on 6.1, this is question of November 2022 that we're going to revise on. We are given to calculate the length of the curve. So there are two curves here. X is equal to this and Y is equal to this, meaning to say, if we take a closer look of these two equations, what is the name that you give where X is in terms of T, Y is also in terms of T? These are referred to as parametric. So here we are given parametric equation. All right. So whenever you work with a parametric equation, you are going to apply different formula as usual that you're supposed to use on the arc length. All right, so I'm going to show you the formulas that are necessary for you to calculate the arc length. All right, so on top here, this is area. All right, so if you check from your formula sheet on page number 7, the top part here is for area, okay, up to this S here. This S is for arc length. This part that you see with S represents the arc length. All right, so I'm going to explain this part. These are the formulas that you use whenever you are calculating your arc length. Okay, so the first one here is the formula that you are going to use when you are calculating the arc length, provided that the limits are on the X. All right, this is for X. All right, this one is for Y. The limits here will be for Y. And this formula that we see here is for arc length. We cannot say for X, we cannot say for Y. All right, it's just the arc length, which is affected on the limits that are taken for a parametric equation. So this one is the formula that you use whenever you are working with a parametric. So we are given, in this case, U1, U2 as the limits, the X du, dy, du with respect to U. So it's a function that was in terms of U. Our function is in terms of X. It's X with respect to T in that case, and also Y with respect to T. So these are in terms of T. So we shall have this in terms of what? In terms of T. That is the only part that we have. So this is the formula that is necessary for us to use in this calculation of the arc length. All right, so I'm going to explain this formula with what we are given here. All right, so then we are given two equations. That's what I was saying. These are parametric X in terms of T, which is 3 cos T minus cos 3T, and also Y, which is equal to, so this is another equation here, Y, which is equal to 3 sine T. So this is 3 sine T minus sine 3T, like this. And we have got the limit of T taken from 0 to pi. So that is the limit. I'm going to show you about this limit later on. All right, so this is what you're given, and you want to calculate the arc length. So from the formula that we have, it states that the arc length, which is equal to S, is supposed to be the integral of the square root of the X du, but this one is with respect to T, so it's the X dt. So it's going to be the X dt. You're just changing that formula that I showed you guys for the parametric, all right? Squared plus, for Y, you do the same thing, the derivative of Y with respect to T squared. And we integrate whatever that we are going to get from this, because this is an expression or whatever that you're going to get here. Maybe it's a single term or whatever that you get, you are supposed to integrate that with respect to T. And the limits being for T. So it's going to be T1 here, and this will be our T2. From these limits, this is your T1, T2. Lower limit and the upper limit, okay? So that means we need the derivative of x with respect to ts for the formula, also y with respect to ts at the formula. So these derivatives, I advise you that you do them separately. In fact, you have to find this here separately, this one. Find this as it is, then you just have to come back and substitute your answer here. So we have to find the derivative of x with respect to t squared. We determine for y and t squared, we combine everything, then we just come back with the answer. All right, so this is what we are going to do. We're going to work this aside. Remember, we need x first. X is equal to, x was given as 3 cos t. Remember, this was 3 cos of t minus cos 3t. That was our x. And I said we are going to need the derivative of x with respect to t squared. All right, so let us start with respect the derivative first. Derivative of x with respect to t is going to give us what? Okay, this is cos. Remember, the derivative of a cos gives us a negative sign. So it's going to be negative 3 sine of t minus, here we've got 3t. So this 3 is going to affect here, but taking what? A negative, the derivative of a cos, remember it's a negative. So it's negative 3 sine 3t, like this, okay? So this is going to give us negative 3, the sine of t, negative, negative, that will be a positive. So this is positive 3 sine 3t, like this. So this is the derivative of x with respect to t. Okay, let's leave it like that. We move on the other stage here, all right? So we are going to need for y in that case, all right? Remember that y was equal to what? Y is equal to 3 sine t minus sine 3t. All right, so this is y, which is equal to 3 sine t minus sine 3t. So just like the previous part, we have to find the derivative of y with respect to t. So differentiate a sign changes to a cos, and it's a positive, so it does not affect anything. So it's going to be 3 cos of t in this case, all right? A sign here, this number multiplies because we've got just like at, so it's going to be minus, already the minus that is here, but sign, it's a positive, it's 3 cos 3t, like that. Sign just changes to positive cos. So meaning to say, we're going to have 3 cos t minus 3 cos of 3t, like this. All right. Here we have got the derivative. We have got the derivative there. But on the formula, we are supposed to integrate. That's why I'm saying these are combination. We are doing derivatives. Later on, we need to integrate. But on the formula, like I said, you need to simplify this under the square root, this part of this part, so that you just bring the answer there. You will not have any confusion. Do not simplify, then you try to bring it back with the, you try to simplify with this integral. You are going to face a lot of challenges there. So just leave it like that, simplify, then you bring the answer here. So we're going to combine these two. We are going to square as we saw from our formula. We are going to need the derivative of x with respect to t squared plus the derivative of y with respect to t squared. Okay, so what does it mean? What does it mean? It means we are supposed to substitute here. So we're going to substitute this is for x as it is. So that is minus 3 sine t plus 3 sine 3t, like this, to the exponent of 2 plus the derivative of y with respect to t, which is 3 cos, that will be 3 cos t. So this is 3 cos t minus 3 cos 3t squared. So we are squaring this, right? So we square this, we square that, we combine. So it is the advantage for us that we are squaring, because, guys, I talked about this expansion of a bracket, all right? If we are given a, let us just say plus or minus b, like this squared, this is going to be equal to a squared plus or minus 2ab plus b squared. So this is the format that we are having. This is being raised to the exponent of 2. So we are having exactly the format that is being presented there. This is what we have as our a, and this is what we have as our b. All right. So the formula is stating that if it is a plus like this, we're going to have a squared, which is we square this. All right. So if we square minus, it's like this, minus 3 sine t like this squared. What do you get? A minus 3 squared is going to be 9, right? Sine, you raise it to the exponent, so it's going to be sine squared t, all right? So that is the part of what? Of a squared. Then if it is a plus, it's going to be plus here. This is a plus, so it's going to be plus 2ab. So you're going to multiply 2a and b, that is 2 times a. Our a is negative 3 sine t like this, times b. Our b is 3 sine of 3t like this. So it's a product of this, which is 2 times minus 3 times 3. So that will be what? 2 times minus 3, that's minus 6 times 3, which is minus 18. So this will give us a negative 18 at the end. So this was going to give us a negative 18 at the end, all right? So here we are going to have negative 18 sine of t, all right, sine of 3t. So we're just simplifying here, expanding of the brackets, all right? Then we move on to the last part, which is of b squared. So the last part said it's b squared. So you square this just like the previous case where we had to square this. So we're going to square 3, that will be 3 squared, which is 9. You also square this sine. So this will be a sine squared 3t like this. So that's 9 sine squared 3t. We are done with this part, all right? Plus, we move on to this part. So we're supposed to add. What are we supposed to add? This also squared. So we're now moving, but this time we are using this part with a minus. There is a minus, so we're going to take a minus, but the concept is the same. A squared, the first term squared, which is a squared. This is your first term, just like the previous case that we had. This is our first term representing a, and this is our b, which is 3 cos t. So the formula is stating that once you can write in this format, it is going to be a squared. Our a, which is 3 cos t. So if you square this, that will be 9 cos squared t. Since there is a minus here, we are going to use minus also there. So the formula states that it's going to be minus 2ab. So our a in this case is 3 cos t. Our b, this is our b, which is 3 cos 3t. The sign here is not affecting b, right? The sign is on its own. It was different from a here. The sign there, the plus there does not affect, same as this minus 3, all right? So this will be negative 2 times 3 times this, which is negative 18 again, 6 and this, that's 18. So that will be negative 18 cos t cos 3t, like that, all right? Then we move on to the last part, which is b squared, right? So this one is supposed to be b squared, and our b is this. We're going to square 3 cos 3t. So if we square 3, going to get a 9. We square the cos also, so that will be cos squared. So this will be a cos squared 3t. All right. So that's how you simply expand from those brackets of a plus b. I say this is the core part. This is the heart of our N6. We just need to know how to apply this, all right? So if we are to take a closer look, we have expanded, which is fine. Do we have any like terms that can be combined? That is what you can ask ourselves. We do not have like terms, all right, which is fine. But there's something that is happening here that I want us to figure out. If you check on the sine squared t here, there is also a cos squared t here, all right? If you check for a sine squared 3t here, there's also a cos squared 3t there. So there's something that is just missing that we just need to properly work on. And what is it that we are supposed to work on? All right. One, even for cos, even for sine and cos here, all right? So we need our identities, all right? For sine squared and this cos squared, remember that sine squared ax plus cos squared ax is equal to 1. Okay? So meaning to say we can take advantage of the sine squared, cos squared. If they are the same, we can get a 1. Then, if we are to also take a closer look of what is happening here, there is a sine t, sine 3t, cos t, cos 3t. There's something that is happening there. We've got identities from the identity of cos. Remember, there's a concept of cos, cos, sine, sine, minus this sine, all right, of cos, cos, plus sine, sine, or cos, cos, minus sine, sine. We know that double identity. So there's something that can, the compound identity, there's something that can happen about that double identity, but we just have to figure it out. All right, let us start with this. In order for us to achieve a sine squared, cos squared, it means we have to take this sine squared together with a cos squared. They must be same. If this is 3, this must also be a 3, all right? But this is just t, so this must be t together. They must be taken together. So we've got 9 sine squared t plus 9 cos squared t. Then we've got the part of also the sine, also this one, the sine squared 3t, this one, 9 sine squared 3t. So we've got also this part. So we've taken this and this together. We also have this term and also this term of a cos. They can be taken together. So that's plus 9 sine squared 3t plus 9 cos squared 3t. Then the part of a cos, like I was explaining, this cos thing and sine thing that is happening there, there is an identity that can be formulated from there. So let us just take in terms of cos, negative 18 cos t, cos 3t, like that. All right, minus here 18, all right, sine t, sine 3t. All right, this is what we have here. So this is now a simplification that you're just making here so that we obtain what? A single term. Like I said, we need a single term from here. So this is what we have here. Sine squared and cos squared, we said this can give us what? A 1. But we have to factor out a 9, which is common, so that we remain with sine squared t plus cos squared t. It is the same thing here on this cos, on this sine squared 3t. Take note here, we are having 3t, that is the major thing. So we factor out 9, we are going to remain with a sine squared 3t plus a cos squared 3t, like this. All right. If we were to factor out a negative here, this is what was going to happen. Let's factor out a negative 18, which is common so far. It was negative 18 there is common. So this is what is going to happen. I want us to be careful on this one. We can write this because if you check t, it's smaller, it's smaller than 3t. 3t is bigger than t. So instead of you having a confusion, start with 3t. So that if you check here, what's going to happen is that it will be a cos like this. It will be cos A, cos B, plus sine A, sine B. Remember, where was this identity taken? For us to have cos, sine. This was taken from the cosine of A minus B. Remember, if we subtract here, it will be a plus. So if we are to subtract, it means A has to subtract B, like this. A minus B, like A minus, it's A minus B. So if this is our A, it's going to be T minus 3T, and it will be a minus 2T. So if you work with the minus, most of you guys, you have a confusion there. So to avoid that, to interchange and start with a bigger number so that if you subtract 3t minus t, is just a 2t, all right? You get a positive as it is, all right? Unless you understand your identities from that N4, of which most of you remember N4, you keep on forgetting, all right? So I'm going to start with the positive. So it's going to be, the bigger one, which is 3t, followed by what? By t. So this will be cos t, all right? Then here, since we have factored negative 18, that will be a positive here. Negative, it will be a positive. But the same order again, starting with the bigger one. So I'm going to start with sine 3t, followed by what? By sine t. All right, so this will be a sine t like this. All right, so this is what we could have taken. Now we can apply our identities. Remember, the purpose of this is that we said this whole sine squared cos squared is equal to what? Is equal to 1. So it simply means you've got 9 times all this part represented by what? Represented by 1. Plus also here 9 times sine squared 3t plus cos squared 3t, which is also a 1. All right. Then we've got minus 18. Let's focus on this here. As we can see from this concept, I said if we can write cos A, cos B plus sine A, sine B, it means cos A minus B. So it was taken from cos A. This is our A, this is our B, this is our A, this is our B on T. So it's 3T minus T. So it is going to be equal to cos of 3T minus a T, of which cos 3T minus a T is going to give us what? Cos 2T. So this is what we obtain from this part. It is going to give us a negative, a single term as cos 2T. So this is minus 18 cos 2T as a single term. Guys, we have to be careful. We have to be careful in our simplification. Identities, these are now applications of your identities now, all right, from our N4. So let us continue here. If we check properly again here, we can combine 9 plus 9, that will be 9 plus 9 there, which is 18. So that's, we have got 9 plus 9, which is 18, minus 18, the cosine of 2t. So from this here, yes, it's in simplified form, like if you check this. But if we are to take a closer look, remember, where are we supposed to substitute? We are supposed to substitute this because remember, what are we simplifying here? We are simplifying this, dx dt squared plus dy dt squared, meaning to say we are simplifying the whole of this thing under the square root. So whatever that you're going to get, it has to be substituted under the square root. So if we substitute this here under the square root, which is 18 minus 18, because are we going to simplify this? This cannot be simplified. Take a closer look. This cannot be simplified. So we have to think along the line so that at least we produce maybe a perfect square or something that we can even determine its square root, because it is supposed to be taken under the square root, or bring something that can be integrated. So what is it that we can do? All right, let's think along our identities. How can we formulate a perfect square? Because there we have got a perfect square on that part. We have got a perfect square. All right. 18 is common here. So let us just factor out 18 first and see the identity that we can formulate. 1 minus cosine of 2t. Let's get back to our identities. From our double angle identities, we've got the identity of cos 2x, which is, all right, cos 2x cannot work because this is a cos again, all right? So we've got the identity, that one for this cos 2 as it is. We're going to take this as it is, all right? There are 3 identities there. So if we work in terms of 2t, remember it can be given as cos squared t minus sine squared t. This is from our double angle identities, which is the same thing as 2 cos squared t minus 1, which is the same thing as 1 minus 2 sine squared t. These are the 3 identities that can be taken into consideration in place of what? In place of this. All right. So I want us to take a closer look. If we are to take this cos 2t here, this is the one that you want to simplify. If we use this, guys, take like we are increasing. That will be 18 cos. So the chances of us having a single term, they are very, very small. So this one is out. You move on to this one. If you are to substitute a cos squared, I want you to see what was going to happen. This is a 1 here. It was going to be 1 minus, you substitute this one, 2 cos squared t minus 1 like this. It was going to be 1. You expand minus 2 cos squared t. You expand plus a 1. I want you to take a closer look of what was going to happen. You have expanded. This is now 1 plus 1. We have a 2, which is 2 minus 2 cos squared t. Meaning to say, still we can't determine the square root. All right. Let's say we substituted 1 minus this one, 1 minus sine squared. It was going to be like this, 1 minus the bracket of 1 minus 2 sine squared t like this, which was going to be 1 minus 1. We expand by minus here, it's going to be a plus 2 sine squared t. If we expand 1 minus 1, this is going to give us a 0. We get 2 sine squared t, of which this is a single term preferred to this one. These are two terms, it's an expression, and we can't determine the square root of an expression, but we can determine the square root of a single term. So meaning to say, of all these three identities that we are supposed to use, the best identity to use was going to be the last one. So this was not going to work, all right? So this is the last one was going to be the best identity to use, because this was going to be 18 into 1 minus, in place of cos 2t, we said we're going to have 1 minus 2 sine squared t, which we can simplify. So this is going to be 18 into, after simplifying, guys, I showed you, going to have this and this, we're going to get what? 2 sine squared t at the end. All right, but remember that we've got this 18. So 18 can multiply this 2. 18 times 2 is what? 36. So this is 36 sine squared t. We now have a single term that we can determine its square root. So this whole simplification, this whole part, what was it for? To obtain this 36 sine squared t. This was from the combination of this dx dt squared plus dy dt squared. Now that we have simplified, this is the part of the derivatives. So the derivatives, you use them here. You combine every, to get combination now, it's your trigonometry. So it was supposed to be a combination of trigonometry again. So we have the trigonometry part. We obtain this as a single term, all right? So we simplified until we got a single term, which is what? 36 sine squared t. So with this 36 sine squared t, we are going to substitute now into our formula here. Remember, our formula was given as, this is our formula here for the arc length. If we are dealing with what? If we are dealing with a parametric. So therefore, our arc length in this case is going to be taken as the integral of the square root of that part, this one. This is the one that we were simplifying before. We got 36 sine squared t. This is what we got with respect to t. And I said the t1 and t2 are the limits that we are taken, that we are given for t. T1 and T2, lower limit and upper limit. So we've got a 0 and upper limit of 4. So take, guys, a closer look. Here, we were dealing with what here? These were derivatives, all right? dy, dx, dx, dy, to combine everything, you find the second derivative, you find the combination of this dx dt squared plus dy dt. This one, it's no longer derivatives. It's a simplification that is happening. That sometimes it may not be of trigonometric expressions. Sometimes they can be algebraic expressions. Sometimes they can be exponential expression. The simplification here is in your hands. You have to simplify until you obtain something that you can use there to determine as a square root, or that you can integrate, because the later stage here is on what? On integration. If we check properly, where are we now? We are on integration here. After substituting the whole thing that we got there, we are now on integration. So we are supposed to integrate this. So how can we integrate this? That is the question. All right. So if we check now, in order for us to have the arc length, we're going to have the integral, but we have something that we can determine. We can simplify before determine the square root. What is it? The square root of 36. We can determine this. So that is the square root of 36 is 6. The square root of sine squared, because the sine squared is going to be sine t with respect to t. So that means we can integrate. Remember, the integral of a sine, it's a negative cos. So it will be 6 times a negative cos of what? A negative cos of t. All right, that is the integral of a sine. It gives us a negative what? A negative cos. And the limits being taken from 0 to what? From 0 to 4. All right, is it a 4 here? This is cos, guys. This is cos. Why am I? This is pi. Because I'm seeing that I'm working with a cos. Whenever you're dealing with a trig, they use these values in what? In radians. So that is a pi. The limits, that one is a pi. All right. So this is the limit here, which is what? A pi. So here we've got a pi here. All right, so that's a pi and also a pi there, okay? So these are the limits that you're given. So after integrating, you're gonna have your limits, which is the upper limit and the lower limit. All right, so this is what we represent as our arc length. So that's minus 6 cos of t like this. Then we can apply our limits. Remember from N5, how to apply the limits, upper limit minus the lower limit. And I said that if these limits are being applied for a cos, a trigonometric function, these will be in radians. So you substitute this and making sure that your calculator is in radians. Minus 6 cos of t, which is pi, that is our upper limit, minus the lower limit, which is minus 6 cos of what? Cos of 0. And our calculator in what? In radians. Unless you have to change these to degrees, all right? But just change your calculator to radians. That is the easiest thing. Then we just substitute, all right? So let us substitute and see what you're gonna have. So I need the calculator here. All right, where's my calculator, guys? I'm gonna need the calculator. Sorry for that. All right. All right, all right, all right. Okay, sorry for that, guys. Here, I need the calculator somewhere here. Okay, so let us substitute this one. So already my calculator here is in radians, and I don't know when did I put this in radians. Here there's R, but you have to put shift setup, then rad, which is 4, in your calculator will be in radians there. So it's -6. So you're gonna put this on our calculator, -6, all right, cos pi, like this, cos of pi. All right, so this is going to give us what? 6. So we are going to obtain 6 minus -6 cos 0. So this is -6 cos 0 like this. So this gives us -6. So it will be 6 minus -6, and this will be what? 12. All right, so that is the arc length in this case. So we are given arc length. So given this, meaning to say our length is going to be what? To be 12. That is what? 12 units. All right, so that is how you play around with this. All right, you just have to make sure that your calculator is radians. After that, simplify everything properly. All right, so this is going to give us 12 units. You can just even write 12 units. All right, so this was the part of the integration. Now after that derivative part, you substitute now, okay, into the formula that you are given. This is the formula for arc length. So you substitute now that part that we have been simplifying all along, this part of the derivative. We now have it as a single term. Here we just want to substitute a single term, something that can be simplified and can be integrated. That is the whole idea of what? Of your question. All right, so it is the same thing even for the area. You're going to see that. All right, let us check the other question. It was on area, which is the surface area. So calculate the surface area generated given by the curve. All right, so this is not a parametric, it's just a normal equation. So we're given our curve is given by the 6.2, y is equal to the half of e to the exponent of x plus e to the exponent of minus x. All right, so what is important is to note where these values are being taken from to. From where to where. All right, so our x values are being taken from x is equal to 0 to x is equal to 2, which could have been written as x is greater than or equal to 0, but less than or equal to 2. It is the same format that they are presenting. But now we're given this area is supposed to rotate about the x-axis. It's important that you note that it is supposed to rotate where? Because on your formulas here, all right, let's get to our formula sheet. Like I said, these are the formulas for area on top. This one is for the arc length. This S is for arc length. Then the A is the one for the area, these ones. All right. So we're given that our area is supposed to rotate about the x-axis. So these are the formulas that we have for area. All right. We have all the formulas here. All right. I think there's another formula that we do not have. Okay, I'm going to figure out. All right. So this is what we have for the area. One, we've got this AY that we see here, all right? It is given in terms of X. This is supposed to be AX. That is the that is the mistake that just happened here. This is AX, this one, all right? Which is given by the formula 2 pi, this would be 2 pi y in this case, 2 pi y in this case. All right, why did they do this, these guys? All right, this formula is supposed to be 2 pi y, all right? Then this is dx, all right, with respect to x, dy dx like this. This is the formula that we take on a condition where our x is taken from the limits a to b. All right, so this is the surface area for the when it is rotating about the x-axis, all right, which is the same as this one here that we see on this part, which is where is it? This one for AX, this one for a parametric. This one is given when you are working with what? With a parametric, all right? When you are dealing with a parametric, okay? Then we also have this one, AY, which is equal to 2 pi x, all right? Which is equal to 2 pi x plus 1 over this, which is another formula. I think there is another formula that we are supposed to have there, All right. All right, no problem. I'm going to talk about that in our simplification later on. But that's it. So this one, it was actually a mistake here. Unless if you are to write it this way, maybe you want to, but that is AX there, supposed to be AX, all right? Then this will be 2 pi y with respect to what? With respect to X. As long as it's with respect to X, it's around what? The X-axis, all right? So I'm going to talk about this. It was just, I don't know, how do they print out this? Okay, anyways, let us talk about this here. So from this one, we said if it is rotating about the x-axis, all right, our area with the respect to the x in this case, which is our surface area, is going to be taken from 2 pi y like this. So this is 2 pi y. Then we're going to have the square root of, all right, so we're going to have the square root of 1 plus, all right, so that is 1 plus the y dx squared, the y dx squared like this with respect to x. This is the area that we are supposed to have on a rotation about the what? About the x-axis. On a rotation about the x-axis. Okay. So what does it mean here? 2 pi is a constant. All right, so you can even take it out of the integral. So it's going to be ax is equal to 2 pi, the integral of y, then we've got the square root of, in this case, you're going to be left with 1 plus dy dx squared with respect to x. All right, so on our formula here, we can see that we need the derivative of y with respect to x, and we have to square this and simplify, just like the previous part. We have to simplify this part under the square root to a single term, just like the previous case where we had to simplify. So let us take our y here and simplify it. So remember that y is given as a half into the bracket e to the exponent of x plus e to the exponent of minus x. So in order for us to differentiate this, what are we going to do? Okay, if we take a closer look, here we're just going to differentiate. It's like half is affecting everything. So the derivative of y with respect to x, we simply need to differentiate. E remains as e minus e to the exponent of minus x. We drop this negative one. The derivative of minus x is what? It's minus, so it will be plus minus e to the exponent of what? Minus x. So this will change to a minus. But there we have to simplify on this formula. We have to simplify 1 plus this dy dx squared. We have to simplify this. So what is the one that we'll get? Okay, so this one is part of the formula, so you just have to write as it is 1 plus dy dx squared. We are going to square this, so this is a half into e to the exponent of x minus e to the exponent of minus x, like this squared. So we're supposed to square that part. All right, so let us square and see. So this is going to give us 1 plus, if we square 1 over 2 squared, that is going to be 1 over 4. All right, we expand this e to the exponent of this part that we have here. We are supposed to expand to the exponent of 2. Remember the concept that we talked about, e to the exponent of x minus e to the exponent of minus x squared. Remember the expansion of a squared, which end up give us a squared minus 2ab plus b squared. Guys, now we're supposed to be used to this, all right? So our a squared, which is e squared. So it's going to be e to the exponent of x like this squared. So this simply multiplies each other. So it's going to be e to the exponent of what? Of 2x. All right, so that will be e to the exponent of 2x. Okay, then we move on. Minus 2ab, this is our a and our b. So it's going to be minus 2 times a, e to the exponent of x times b, e to the exponent of minus x. So this will be minus 2 e to the exponent of what? We are adding here because we are multiplying the bases which are the same. So we're going to add the exponents. So if we add x plus minus x, that's what? That's a 0. X minus x gives us a 0. So it will be minus 2 e to the exponent of 0, that's a 1. So minus 2 times 1, that will be a minus 2. All right. Then we move on to the last squared, the last term squared, that is e to the exponent of minus x squared. So if we square, it will be e to the exponent of minus 2x. We multiply the exponents. So this is what we are obtaining from what? This part of what? Of our e in this case here. So if we take a closer look here, what it simply represents, this whole part here, guys, there was no need for us to even expand here. If we check it properly here, there is no need for us even expand. But anyways, because there is a 1 that we have that need to be added, so there is a need now for us to expand. That is the problem, all right? So what can we do? We can add combined, because we're supposed to have a single term, so this will be 1 plus, so it's going to be 1 plus, if you multiply by this e throughout by 1 over 4 throughout, this will be e to the exponent of 2x over 4 minus 1 over 4 times 2 is going to be 2 over 4, which is a half, which is minus half. But there's something there because it's over 4. I want us to maintain the denominator there. So just leave it like that, plus e to the exponent of minus 2x over 4. We have multiplied by 4 by each and every term. Remember, we can add, and we know that 1 as a number, if we write it in the denominator of this same denominator that we are given, it's the same as what? It is the same as 4 over 4. So this one here is same as 4 over 4. So if it is the same as 4 over 4, it means we are going to combine everything under the same denominator that we are given. So if we combine everything, we're going to have e to the exponent of 2x, 4 minus what? 2. So if we subtract 4 minus 2, that will be a plus 2. We are combining the numerators, all right, plus e to the exponent of minus 2x like this. So this is what we are going to have at the end. All right, as if this is not enough, because if we check properly here, I want us to be careful. On this part here, I want us to be careful here. E to the exponent of x, right, minus e to the exponent, minus e to the exponent of minus x squared. It gave us this part of e to the exponent of x minus 2 plus. Take note, this here, it was a minus, but the whole part was being raised to the exponent of 2, and here it was a minus. All right, if you check properly, this is the same exact thing that we have, only that here it's a plus 2, but here it was a minus 2. So if this was a minus 2, which is the only different thing, if this is minus 2, it means our bracket is the same as that one that we had before, but it is only what? A plus. So we can factorize this part that we see here. It is the same part that we had before. So this simply means we had a bracket of e to the exponent of x plus e to the exponent of minus x to the exponent of what? Of 2. Just like what we had before, it was the bracket of e to the exponent of x minus e to the exponent of minus x squared. This is the one that gave us this, all right? The only thing that changes now, this is a positive 2, so this is supposed to be a positive here. So that is the only thing. So it's just going to remain as it is, e to the exponent of x minus this to the exponent of 2. But now it's a positive. That is this part that we see here. Everything over 1, everything over 4. So that's how they test you. They want to test you. Can you figure out a single term? Now we have a single term like this. So this whole thing that we had here, this whole part here that we are given here on our formula, this whole thing that you see here is the one that we have been simplifying here. 1 plus dy dx squared, this one. This is what we have been simplifying all along. And what we got here is a single term. After simplifying, finding derivatives, using our normal simplification, we got a single term, which is this one. So we're going to take this bracket as it is. So that will be our area with respect to x is equal to 2 pi. The integral of also y here. Let's start with this y. What is y representing? Y represents the y that we had the original, from the original equation, this one. This is our y here. Remember, y is equal to this. So you substitute that y as it is. So y is equal to a half of e to the exponent of x plus e to the exponent of minus x, like this. All right, times the square root of this here, which is the one that we have been simplifying all along here, which we got here as a single term. That was this part. All right, so here we got this as a single term, which is e to the exponent of x plus e to the exponent of minus x squared, like this. Everything over 4. So this is a squared, everything over a 4, like this. And we're going to integrate the whole of this with respect to x. All right. So that is where our derivatives played a role here. They are done. The derivative, the differentiation is where it played a role to give us this single term. After that, forget about derivatives. We are now under integration. So this is the question that is now, it's a new question that we have now. We are now thinking of another topic, integration. How can we integrate this? Meaning to say our simplification has to be written in a way that we can be able also to integrate. All right. Let us check what we have. We can see that there's a square root, and we know that the square root of a squared is going to be this bracket as it is. Also, you can determine the square root of a 4. So this can be simplified further. So this is 2 pi. We can even take this half outside. All right, you can even take this half out of the integral of this one. So it's 2 pi times a half, like this. The integral of e to the exponent of x plus e to the exponent of minus x, like this. All right. So like I said, we can determine the square root of this whole bracket to the exponent of 2 means is that bracket as it is. So it's e to the exponent of x plus e to the exponent of minus x. Remember, the square root of x is squared, it's x. So the square root of sine squared x, it's what? It's sine x. The square root of anything squared is going to be that term that is being squared, all right? Then we also have a 4 there. What is the square root of 4? The square root of 4 is a 2. So this is over 2 with respect to 2, with respect to x. So take note, this half here is this one that was on this part. What about this one, the 2 here? We have to take it also out of the integral. So meaning to say out of the integral, this will cancel here that we already have half and a 2. So we're going to take this half out of the integral. So meaning to say our area with respect to x is going to be given as 1 over 2, the integral of. If we take this out of the integral, what are we remaining with inside of the integral? That is the question. So inside here, if we check properly, we are remaining with these 2 terms because we have taken these 2 out here. Right? We have taken these 2 out. It's no longer there. So we are remaining with this term and this term. And are we not seeing something there? Are we not seeing something there? What does this term represent? These are 2 terms which are the same. So we are back again to that expansion of a plus b squared that we did before, if you still remember, because these 2 brackets are the same. So it can be written as e to the exponent of x plus e to the exponent of minus x squared, like this. All right, with respect to x. And we expanded this e to the exponent of x plus e to the exponent of minus x squared. Isn't it that the one that we expanded before? It's only that now I erased that one. All right, no problem. I erased this, but we had that e to the exponent of this expansion, which gave us, which ended up like ax is going to be a half the integral. Remember, we're going to raise to the exponent of 2, which is going to be a squared, which is e to the exponent of 2x plus 2ab. So it's going to be plus 2ab e to the exponent of x times e to the exponent of minus x. This will give us a 0. So that's 2e to the exponent of 0, which is what? A 2. So that's plus 2 plus b squared, which is the last term squared. So it's going to give us e to the exponent of minus 2x. I hope here we are still together. So that's it. We have expanded these brackets here that we are given. So you can even expand them if you want. Properly write 2 brackets, expand. But guys, N6, you won't be able to finish your question paper. It has a lot of things. If you want to do it nicely that way, you won't be able to finish the paper because it has a lot of things. All right. Then the other thing here is that on our formula, we just wrote our formula. It has no limits. You saw that. All right, the limits here it's x from 0 to 2. So that will be our x1, x2, x1, x2 here. So that's from 0 to 2. From 0 to 2, the limits from 0 to 2, 0 to 2, and so on. So here we're just integrating. Now we're just integrating. So can we integrate this? Having our limits from 0 to 2, that means our area with respect to x is going to be 1 over 2. Remember the integral of e, you find it's e as it is, the function of e as it is, over the derivative of this. So the derivative of 2x, which is 2, plus, if we integrate 2 with respect to x, it will be 2x. Remember, it's a constant. Then the same thing on our e, we said whenever we are working with this e, all right, if we integrate this, we are going to have what? We are going to have this as to the exponent of, guys, there is something here. When I canceled here the half and the half, I left with a pi here. You see, this is the advantage of also looking back, all right? You can see here, before we talk about this, there's a pi there. There's a pi. All right, you see this thing of working with softwares, guys, you even forget something small, very, very small, and it affects everything. All right, so here we have got the integral of this, just like this part is gonna be, it was supposed to be e to the exponent of minus 2x over minus 2x, like the derivative of this. So that we've got a negative here, e to the exponent of minus 2x over a 2 like this. Then our limits to up to from 0 up to 2. So that is what you're going to have in actual sense. All right, so here we can just substitute, that will be our area with respect to x is going to be 1 over 2 pi, or pi over 2. So this will be, substitute the upper limit here. So it's going to be e to the exponent of a 4, 2 times 2, that's a 4, plus 2 times 2 here, that's a 4, minus e to the exponent of minus 2, that will be minus 4 over a 2. So this is representing our upper limit, all right? Minus the lower limit when this is a 0 here. If you substitute a 0 here, that will be 1. So it's going to be 1 over 2. Substitute a 0, that's a 0 there. Minus, also this will be 1 over 2. So that's a 0 there. There's nothing that we are getting from this bracket. That's simply a 0 here. So if we take a closer look, this bracket is simply giving us a 0. So you have to simplify this, then we multiply to the 1 over 2 pi. So guys, you see your formula, understand your formula first, all right? The formula with the limits, and also on the simplification, don't forget, like this part, you see almost like left out this pi, all right? So it's something that can even happen in exam. So we just have to be careful. Each and every step, make sure that you cross-check again back to see if you are in the right direction. All right, so we have substituted the limits. So this is just you and your calculator now, guys. You have to substitute. Like I said, this is the only part that we're going to simplify. This here gives us what? This here gives us a 0 on that part. All right, so let's simplify and see what we're going to have. So this part, I'm not going to focus on it, the last bracket, because it gives us a 0, that one, if we check. So I'm just going to focus on these two. So that is pi over 2. So the radian part does not affect for any, it only affects trigonometry. So it does not matter if even if your calculator is in radians or degrees, all right? So this is e to the exponent of 4 over a 2 like this, right? Then we move on here, plus a 4 minus e to the exponent, so we're going to have a fraction here, e to the exponent of -4 over a 2 like this. All right, so this is what I'm just going to simplify. Like I said, this other part here, it gives us a 0, so there's no need for us to write it on our calculator. So this is going to be 49,115. All right, so that's 49,15. So this will be 49,15 to 3 decimal place. You're going to just put a 0 there. That depends with what you're given on the instruction. All right, but if you did 2 decimal place, but 3 decimal place, you put a 0 or just leave it like that. This is area, which is measured in what? In square units. And also for rounding off or for your answers, you can use your calculator shift setup, go to the fix on number 6. So to 3 decimal place, you press 3. To 2 decimal place, you press 2. To 1 decimal place, you press 1. So to 3, you press it's going to be a 0 like that. All right. So this is the simplification that you can even have on your calculator. If you want, you can even leave it like depending with the instruction of the question paper. Here, I'm just showing you guys how to integrate and differentiate this. All right. So this is how your questions might be given as. This is how your questions might be given as. You have to find the derivative. After the derivative, then the integration. That's why we're saying it's a combination. The combination combined. We are combining both derivatives and integration. So that is what you're going to expect in each and every question paper. On question number 6, one question for the arc length and the other question for the area. Just like that. That is question number 6. So expect to have more questions to come from Maths on African Motive.